All right, shall we go ahead and get started and a couple minutes early? I have a lot of ground to cover, so I will go ahead and get rolling. And you know what? If we need to get caught up with somebody, that's fine. Cool. Hi, everybody. It's nice to see you. My name's John. Hold on one second. Let me do one more thing here. Great. Yeah. So my name's John, and I'm going to be reporting back today on what might be some foreign territory. So just as a quick show of hands, who here has sent a blockchain transaction? Cool. About a quarter of the room, maybe. So out of you, who has written and deployed a smart contract? I guess if you've deployed a smart contract and not sent a blockchain transaction, I'd be a little confused. But anybody written smart contracts? Okay, touched on it. Who has stored or read data off of IPFS, the interplanetary file system? Cool. And who here has worked with private keys and digital signatures? A couple more. Okay, cool. Great. That's very helpful because it helps me triangulate where to kind of level set. So here is what we're going to talk about today. I'm going to do a quick introduction of myself. I'm going to talk a little bit about bridges as a system of tensions to connect distant spaces. And then I'll pause for a very important aside. And then I'll talk about the three pillars of the decentralized geospatial web and the Astral stack, the tools, standards, and services that we're building for that world, and then a bit of future work. To kick off, one question I've been asking with a lot of my friends over the last several years is how can we build a better web? It's 2025. Obviously, the technologies we have are unimaginably amazing, but we've also have enough kind of behind us in the evolution of the internet to understand some unforeseen and perhaps unintended consequences that have been created as these technologies have grown to civilizational scale. So I think it's as good a time as any to ask, how can we build technology that helps us live well, technology that enhances dignity and supports our communities and ecosystems? What have we learned, and how would we maybe do things a little differently? So who am I? I'm John. I'm the founder at Astral, which is an open source project bridging geospatial data technologies and the decentralized web. I lead a design engineering consultancy called Sophia Systems, and I'm a research affiliate with Professor Taylor O'Shan, who's in the room, at the University of Maryland, working with his team at the Easier Data Initiative and the Decentralized Geospatial Collaborative. And over the years, I've worked with Ordnance Survey on developer ecosystem and innovation. I was a co-founder of a tech startup called Toucan Protocol. I co-chaired a working group at the World Economic Forum looking at Web3 technologies for climate action. I have a master's in spatial data science and visualization from University College London, and for a very brief spell, I was a cliff diver at Casa Bonita, which is Denver's favorite Acapulco-themed Mexican restaurant stroke theme park. That was my first job out of high school. You can ask me how I got fired after the talk. So I'm here, as I said, representing two different worlds. The first here is the geospatial web, and especially FOSS, free and open source software. There's a lot of love and a lot of alignment here. FOSS-GIS is built on openness, on interoperability, puts a lot of emphasis on user control, kind of interpretability. And in 2025, a lot of the way the web has gone, because very strong incentives exist, and it's also lots of technical complexity, has kind of driven us here to cloud locked data, proprietary APIs, and brittle trust chains. So we've got a lot of challenges in verifying provenance and making sure systems are durable and resilient. And then on the dark side over here, we've got the decentralized web emerging, which actually, if you kind of look past the headlines, shares a lot in common with FOSS values. And I'll talk a little bit more about this, but I see it as an effort to re-architect the internet to embed those values on a kind of technical, architectural level. So, as I say, I've been working on my dual citizenship, and that's for a very specific purpose, which is to try to build bridges between these two worlds. The interesting question here, I think, is what do these two domains have to offer each other? So this isn't about recreating what's working well in the geospatial world, but, make it decentralized. This is what kind of decentralized web tools are coming up that might enhance or complement what we can do well in the GIS world, and vice versa. How do we bring geospatial data technologies into these applications where it's mostly missing? We're not trying to reinvent anything, and we're not trying to develop new non-conforming standards. A brief bit on the decentralized web. This is an effort to build a more resilient and user-centric web. I'll give an optimistic take of the vision, and then a little bit about tools and technologies and the state of play. This is extraordinarily wide and varied, but the sort of top line technologies you'll see are blockchains, smart contracts, consensus networks, crypto tokens, whether those are fungible tokens or NFTs, maybe digital governance systems like DAOs, but there are also a lot of decentralized web technologies that don't go anywhere near blockchains. Things like decentralized identifiers, peer-to-peer data management systems. People are building social networks on decentralized systems, like at Proto and Blue Sky. So there's a whole kind of movement to think about, all right, now that we've seen how these apps and services operate at scale, how would we kind of reconfigure the guts so that it makes them more durable, more reliable, and hopefully a bit more user-centric, shifting power to the margins and away from the platform providers. Hallmarks include distributed or decentralized systems with no privileged actor. User control is, accounts are most usually authenticated with digital signatures and private keys, which is a really subtle architectural shift in identity management that puts a lot more control and responsibility with the user, because if you lose your private keys, you lose access to your accounts. And a strong emphasis on verifiability, whether that's trust through transparency and what I think of as technical mechanisms rather than policy-based mechanisms. So build rules into the system rather than applying them after the fact with an SLA or something like this. And another major emphasis is on openness and composability, that these systems are kind of designed, at least in the ideal, to have stable interfaces and encourage kind of innovation and building and remixing, and kind of smart contracts are a prime example of that. There are some drawbacks, of course. There's lots of immature tools and immature systems, lots of abandoned projects. It's about 15 years old, really. Like in the last 10 it's taken shape, which feels like a long time, but I mean, I kind of remind myself that how far things have come in the last 10 years. But that said, also, there's a lot of complexity, and it's quite difficult to kind of parse the technical language in Web3, similar to geospatial. So one of the kind of tests in my dual citizenship work was learning both languages so that I can kind of translate between them. To that point on controlling accounts with private keys, that introduces some difficulties in providing guardrails to manage risk for users, like account recovery. And there's a lot of work that's been going on within the blockchain community to create more graceful or resilient account management strategies. So in 2025, if you haven't been following for a little while, there is a huge amount of innovation and a real kind of Cambrian explosion, as I see it, in the ecosystem. Decentralized finance is kind of the biggie, right? The blockchains have interesting properties that allow you to build currencies and financial applications on top of them. So those are kind of now hitting the mainstream, especially with some recent regulatory clarity. There's also solutions for scaling the throughput, the number of transactions that blockchains can handle. A lot of those revolve around building what they call layer 2 systems, which kind of bundle up a bunch of transactions and then anchor them on a main layer 1, so you can kind of build layer 2s that have different properties to a more secure layer 1 and increase the throughput in that way. So like decreasing the amount of time it takes to get a transaction validated, for example, or the amount of data you might be able to store. And then one other thing that's worth mentioning is a real emphasis within the ecosystem on privacy, on user privacy. There's a lot of work going on here. One kind of particular domain that deserves mention is zero-knowledge cryptography, which involves encoding computer programs in cryptographic circuits so that you can kind of mathematically prove that a software program was run in a certain way and an output is a certain output without revealing the details of sometimes the data inputs and sometimes even the software program you're running. That's about as much as I can say about zero-knowledge cryptography, so it's kind of moon math. But anyway, so yeah, it's kind of a jungle, but there's a lot of interesting stuff going on there. And it took me a very long time to make sense of this really diverse and sometimes conflicting set of technologies. But I experienced a big unlock when I began to view Web3 not as a collection of blockchains or networks or protocols or products or apps or communities or ecosystems, but as a set of design principles. And I kind of sum those up as Web3 systems are open, platforms and services cannot be enclosed or revoked, they're durable, the systems, incentives, and the governance structures around them are built to outlast us, and they're user controlled. They empower participants without exposing them. So there's a whole sort of thicket of buzzwords and jargon that surround blockchains, like permissionless and interoperable, verifiable, composable, all these words that all have really interesting meanings, and I see these three as kind of, each of those properties can kind of basically be rolled up into this, and this makes it easier to explain it to like my dad. So I'm going to call out two specific technologies in this ecosystem as relevant here, but I have to say there's a lot more to it. So the big one is Ethereum. Ethereum is called the world computer. So this is a smart contract platform. So it's a blockchain that's managed by a consensus network of a decentralized network of infrastructure providers that are running what are called the validators. And essentially the function is to create a globally accepted sequence of update transactions. That's essentially what it is, right? So you can think of it as a special type of database that, because it's managed by a decentralized network, it has some interesting properties like it never goes down. Once it's sort of in the history, it's never going to be changed. And because accounts and identities are managed with wallets and private keys, users control their own assets, their own accounts, their own data, and nobody can mess with it without access to that private key because users are authenticated with digital signatures. So there's obviously quite a lot more to say about Ethereum, but I think I'll probably leave it at that, other than to say that I imagine a smart contract as a special computer program that's stored on a blockchain that has data and functions. It's actually really like an object of a class. When you deploy a smart contract, it's like instantiating an object, and that has attributes and methods, and it's essentially like a permanent service stored on the blockchain that you can invoke, and you send in a transaction addressed to the smart contract instance, specifying the method you'll call, specifying the input parameters, and the function will run. It will update the state maybe of the data that is stored in that smart contract. Maybe it'll call other smart contracts, so they're designed to be able to be composed together and plugged together. And that kind of fundamental pattern is the basis of a huge amount of the innovation that we're seeing in Web3 and especially in the Ethereum ecosystem. Another piece of technology I'm going to mention, which is highly complementary to Ethereum, is called IPFS, the Interplanetary File System. So this is a peer-to-peer hypermedia protocol. And it involves using what are called content identifiers to identify data instead of location identifiers. So most URLs we see specify a server and then a resource on that server, and Doesn't matter if you have that exact same file on your computer or at your next door neighbor's computer, it's only going to go look on that particular location on the network for the file. So this is more of a BitTorrent kind of peer-to-peer style content system, and it uses a kind of clever way of using cryptographic hashes actually as a main part of the identifier, so that you kind of have checksums baked into the content identifier. So that has some interesting properties. And so this is a sort of permissionless network. Anybody can run an IPFS node. Anybody can download content or post content to IPFS. But there's another question to that durability point. How do we know this content is going to be here next week, next month, next year? The Protocol Labs team, which built IPFS, built another kind of incentivization system to ensure that storage providers host that content for the long term, or for however long someone might pay for storage, and that's called Filecoin. So those are two kind of complementing systems. It's very confusing. Filecoin is another blockchain. It's like I say, it's a thicket, but I think I've kind of sketched out enough of the context to probably move on to what we're trying to work on at Astral. So one major insight is that location data is by and large missing from the decentralized web. And in 2017, I showed up with a geographer's lens to Ethereum, and I kept kind of asking, where is all the location data? Tried to build a whole bunch of different products, apps using location data, and kept running into the same problems. The basic tooling wasn't available. And so, you could obviously use common tools in the sort of FOSS world, Turf, GDAL, Shapely, GeoPandas, but it didn't really kind of make location data fit for purpose within this different computing paradigm. And I kept kind of asking, like, where's the library import? Where's the service I can hit? Like, how can I do this super complicated thing with a few lines of code? Taking a lot of inspiration from PostGIS, which, you have a super unopinionated database management system. You install the PostGIS extension. It's still incredibly unopinionated. They're not saying anything about what these records represent or anything, but you suddenly have these superpowers of being able to work with spatial data, because it adds some data structures and schemas and adds a pack of functionality. And that's kind of in essence a lot of what we've been doing, which is why one of the framings I use is this is a spatial extension for the decentralized web. I'm going to take a very brief moment to recognize an elephant in the room, which I overlooked when I was going through the drawbacks of Web3, which is a topic that I often describe as horse shit. Sometimes it's monkey business, and that's, of course, the headlines that everybody sees. Crypto's a scam, crypto's for criminals. Money makes people crazy, and because decentralized web, one of the most powerful applications is money, it's attracted a whole lot of fraudsters, criminals, morally bankrupt, and that's part because of one of the design properties. It's open. Anyone can join. So if anyone can join, you're just going to be allowed to join. Fraudsters and criminals are going to be allowed to join. So I'm trying to look past the surface and see what's going on under there, while still acknowledging that this is a real problem, and that there are really interesting approaches to trying to suppress this kind of misbehavior on the decentralized web. So I can see we've got about 10 minutes left, so I'm going to probably speed up. So looking at these two worlds, lots of challenges in the decentralized web, or the geospatial web, and I'm trying to think, how do we bring decentralized web technologies over to support that? And to do that, let's frame some of the top line ways that geospatial data, kind of top functions in the geospatial data world, collect, store, analyze, and consume location data, right? I think we can kind of generally bin it up into those four categories. To complement those in the decentralized web, Taylor and I have identified what we see as three pillars of the decentralized web, which are proof of location, verifiable geocomputation, and peer-to-peer spatial data management. So I'll just quickly pause and say we're really trying to serve the full breadth of the kind of work that's going on in this conference. So that includes location-based services, where a user's or device's position is checked against a context that might be within a polygon or bounding box. It also might be, what are the nearest records to me, and then some action is taking, whether that's UI feedback, webhook, data update, maybe invoke smart contract. And then the other sort of broad thrust of GIS is spatial intelligence. Data collection is analyzed and then used for decisions, serve it to people, maybe visualize it, consume it in some kind of way. So I'm going to talk a little bit about these three pillars briefly, and then talk about some of the tools that we've been building to serve both of those kind of patterns, location-based services and spatial intelligence workflows. So proof of location involves trying to make verifiable claims about where and when events occur. And so this is kind of based on this insight that on the open web, the client-server lock-in between a mobile device and the server is broken because users control their accounts with private keys. So we're saying rather than kind of trust an IP address, which can obviously be spoofed, how would you actually create a pack of evidence to support a location claim and process that evidence to assess how well it corroborates the claim, and then make kind of interesting access decisions or decisions about whether to trust that on that basis. So this is honestly kind of like a cyber-physical computer security question. Verifiable geocomputation is a broad category that involves getting confidence that spatial analyses were done correctly. There's lots of different flavors of verification we're researching that involves pushing it to smart contracts, encoding it in zero-knowledge circuits, and other ways. But the idea here is that you get transparent, tamper-resistant results, and some of these techniques also kind of strip the raw input data out and afford the user privacy while still providing the verifier with confidence that the computation was performed correctly. And then peer-to-peer spatial data management involves the distributed storage and retrieval of geospatial data. So that content-addressed interplanetary file system, what would we need to build to store satellite imagery or vector data sets on that and still have efficient querying and fetching like you do with a lot of the cloud-optimized formats we have that we're talking about here. So I'd like to talk a little bit about the Astral stack, and okay, I got 5 minutes, that's pretty quick. The first is the data layer. Next up is what we call the credibility layer, which has to do with how do we trust in the data. That's where I'll talk a little bit about location proofs. We're building a developer platform, and then on top of all of this, the application platform, or the apps layer. And each one of these is useful maybe on their own, but they're really designed to kind of interlock and connect up all the way up to the top of the stack. With this, it basically can serve industries where location data underpins some sort of valuable transaction or interaction, where there's some sort of incentives around that. Whenever there might be an incentive to lie about where things happened or how a process was performed, this might be really useful. So on the data layer, we've been working on a new protocol for verifiable location records, which we call the location protocol. We have two implementations right now. One, the beta is on, or the alpha, I guess, is on a platform called Ethereum Attestation Service, where you can register, create signed location attestations or location records, hold them off-chain privately, or register them on an EVM-compatible blockchain like Ethereum. We also have another team, independent team, scoping out an implementation on @proto, which is the protocol that Blue Sky is built on. So this is a sort of meant to be a bit of an abstracted layer so that location data records are interoperable across the decentralized web and into the centralized web, and bringing some verifiability and attributability properties to that. And then we have an indexer we've built to serve these records through OGC API features, endpoint conformant APIs, as well as GraphQL endpoints and other things like that. I think we can kind of slice and dice this up however we want. So the location protocol is not a 15 standard, don't worry. It is a meta format for structured, cryptographically signed location data. So if you're signing GeoJSON, cryptographically signing GeoJSON, this is meant to bring just a little bit of structure to that for interoperability. It works with any location data format and adds verifiability to it. That consistent structure makes it portable across centralized web, decentralized web, peer-to-peer data systems, and it's built to align with OGC standards. We're on the OGC blockchain domain working group, but this is still early work. So really comes down to basically a few core spatial fields. The big one is location, which is essentially where there might be a kind of location data artifact like a GeoJSON object, or a reference or link to any sort of geospatial data or any location data. And then it optionally has extension fields. So I kind of think of this as if you create a new geometry table in PostGIS, you have to have the geon column. The spatial reference system is embedded in that data artifact, and then anybody can add any other columns fit for their use case there. So I think of this as, oh, I built a cool table where, of course, the thing we have is all the green dots. I might need to post this so you all can look through this yourself. And here's a code snippet, which is basically some TypeScript for connecting to Ethereum and creating a new instance of a wallet, and then creating what we call a location attestation or a location record that kind of signs a GeoJSON point, cryptographically signs it. A verifiable location record is a user-controlled atomic record in a universal geospatial database. I am realizing we're getting close here, so I'm going to try to snip through this. I talked a little bit about the Astral indexer. We've also been working on, for that spatial analytics workflows, IPFS optimized geospatial data technology. So we've built a Python client for connecting up stack catalogs and stack items to satellite imagery scenes stored on IPFS. And we've also done some research on what we call IPFS optimized geotiffs that kind of take that same patterns that you have in COGS, but kind of tweak them for this content address system rather than for kind of a cloud-hosted system. Again, I probably need to share this. I'll share this deck on Twitter. On the credibility layer, we're building what we call a location-proof framework, which is an open source library of location-proof plugins that allow for devices to collect signals from different proof of location systems and bundle them up together so that a verifier has evidence that a location claim is true. And then evaluation functions for processing that data. And this is because on the open web, it's a bit difficult to trust when a user makes a claim about a location. So roughly we have the location claim, which is a statement that an event took place somewhere, signals collected from different proof of location systems like latency, pings, ambient identifiers, social records, maybe an event checker checks you in, an evidence evaluation process that analyzes that data in relation to itself, and then the output is what we call a location proof, which is a portable, user-controlled data artifact that it provides a kind of quantified assessment of how well the evidence supports the location claim. So what we're trying to do is bring a new primitive to the web, which is a location proof that can kind of, we think, unlock a lot of really interesting use cases. On the platform level, we're building Astral Location Services, which includes an endpoint for verifying location proofs and processing that evidence against itself, and then a geospatial policy engine, which is kind of just a wrapper around PostGIS, run in a verifiable way so that you can do those context checks. Find me the 10 nearest people, check if this point is in this polygon, and then output signed policy attestations that can be anchored on a blockchain and trigger smart contract interactions. Opens up some interesting kind of geo-gated smart contract use cases. So yeah, I think I need to really burn through this or else Chelsea's gonna give me a hard time. But this is really kind of designed to link up edge devices with blockchains. And just to make sure I'm clear, a lot of this is designed to interoperate with blockchains, but a lot of it doesn't, blockchains aren't necessary for this picture. This technology can still be useful with something like a centralized server verifying the location proof, and okay, we now actually have real evidence basis to believe that this person is here, they can do this, or we need to push some sort of step of verification to them. And then on the app layer, the question is now, what can we build? And we have a whole bunch of ideas: local currencies, logistics protocols, local voting, But I think there's also a lot of more vanilla things, and if anybody's inspired or has questions, I would be very, very curious to talk to you after the session when you also ask me how I got fired from Casa Bonita. So in review, the Web3 design principles are, Web3 systems are open, durable, and user-controlled. We're trying to build bridges between the geospatial web and the decentralized web. We've identified 3 pillars: proof of location, verifiable geocomputation, and peer-to-peer spatial data management systems. And we're building a whole suite of tools and standards that are useful on their own, but are really designed to interoperate with each other to try to unlock kind of what might be we'd be able to unlock if we can become master of both of these worlds. 1 minute, 1 minute to go. All right. I don't know if we have time for questions, but maybe while we're switching out, I'm happy to answer any questions.
To be clear, I'm just a volunteer. I can't
Oh.
speak, but Martin, the next speaker, might.
Okay, great. Martin, why don't you get up here and get ready?